lot of word problems that connect distance, speed, and time. If you've ever taken a science class or physics class that deals with those, do you know your formula that relates distance, speed, and time? Not very good?
Distance over time equals speed.
Distance over time equals speed. Sometimes they use V, doesn't, are you okay with S for speed? You can use V for velocity. Now, this formula is actually easy to remember. Have you ever seen a speed limit while driving? Can you give me an example of a speed limit you've seen while driving? 90 kilometers per hour. When they give you a speed, they tell you kilometers per hour, which is a distance over a time. And now you've got your formula. And this formula can be rearranged in a whole bunch of different ways, right? Can you see that if you wanted to get the d by itself, you'd have to multiply both things by t. So you have a different, you could have this as the formula. Ooh, STD, that sounds like something you don't want to get. Maybe we don't write the formula like this very often, but we could, right? And if you wanted to get the t by itself, well, you could divide both sides by s. Right. So we can take the one formula, and this is the one that I always start with. I always start with that because I'm like, oh, I know speed limit. It's distance, kilometers per hour. The per is like divided by. So I have kilometers on top, distance on top, hours on the bottom, distance over time. So there you've got your formula. Whether you like it or not, I just made you memorize it really easily. And from that, you can rearrange it. Then what we're going to do is we're going to read our question and look at what we're talking about, and we're sort of going to make a chart of the data that we're given. So on a canoe trip, Patan paddled upstream a distance of 10 kilometers. Does anyone know anyone Patan? I don't either. I was like going, yeah, no, I won't even. It's like, put an S in front, it's like a bad name. I was going to call, you know, I don't know, like a twin, I'm not sure. Okay, paddled upstream a distance of 10 kilometers. On a return trip downstream, the average speed of the canoe was 5 kilometers greater than its speed upstream. Right? Then simplify an expression for Patan's total paddling time in terms of the average speed upstream. You read this question, it seems very difficult. Like, I don't know where to start. So what we're going to do to start is we're going to make a chart with distance, speed, and time, and what's happening. So we have two things happening. We have upstream and downstream. Maybe. There we go. And for this, we're going to look at distance, speed, and time for what's happening. This chart is just going to let us organize our data in a nice way. Do we know the distance he traveled upstream? So then you read the whole question. Does it tell us how far he's traveling upstream? Yes. 10 kilometers. Perfect. Do we know how far he's going to travel downstream? Well, he turns around and comes right back to where he started, so that does it make sense? Those two distances are the same. 10 kilometers. Okay? Do we know the speed? We don't know the speed, so we're going to introduce a variable. You could call it x, you could call it s, whatever you'd like. But if I introduce x here, because it does say in this question, in terms of the average speed upstream, so they're kind of telling us that they want to have that as your variable. If that's x, does it make sense that you're going faster downstream, and it tells us you're going 5 kilometers per hour faster? So that will be x plus 5. Now, we don't know the time either, but we want things in terms of the average speed. So I'm going to go to this formula for time, and I know that if I'm going 10 kilometers at this speed, my time will be 10 divided by x. And the other one is going to be 10 divided by x plus 5. Okay? So that's using the formula. In our chart, we are only allowed to introduce one variable. Otherwise, our math gets really hard. Can't solve anything. So once we decide that upstream is going to be our x, everything else we don't know has to be written in that x. I don't know my time, but I know that my time is always distance divided by speed for my formula, so I can write that. And then if this is the time upstream, and this is the time downstream, does it make sense that our total time would equal this one plus this one? And then how do you add fractions? You need a common denominator. So this one I need an x plus 5 on the bottom and an x plus 5 on the top. And this one's missing the x on the bottom and the x on the top. So doing that, I will get common denominator of x times x plus 5 plus a common denominator of x times x plus 5. And here if I distribute, I'll get 10x plus 50. And here if I multiply, I got 10x again. I can now write this as a single fraction because my denominators are the same. And I have like terms, and I have 20x plus 50. Interesting here that the textbook doesn't say x can't equal 0 and x can't equal negative 5. Instead, the textbook writes this. X has to be bigger than or equal to 0. Because x was what? Our speed. You can't be traveling at a negative speed. So negative speeds make no sense in this question. We also can't be traveling at a speed of 0. It'll take forever to go 10 kilometers. Literally. Yeah. Oh, I wonder when we'll get there. Yeah, not good. Okay? So that's why the textbook has that x bigger than 2. One circled the question, but our entire next part of this unit is dealing with different kind of word problems, and one of them will be these